I know I said I wouldn't do reaction videos, but I keep seeing these terrible memes about quantum mechanics. It's quite possible that you don't want to know what I think about them, but I'll tell you anyway. In this totally unfunny video, I'll rate the 10 most popular quantum memes. Are they any good? That's what we'll talk about today. As usual, I've been overthinking this, so I'll give each meme 3 ratings and I'll place them on this little triangle. 1 rating is for accuracy, that's how well it fits with quantum mechanics, that's the little nerd icon. The second rating is for effectiveness, how much you learn from it. This is the little teacher icon. And then 1 for how funny it is, each on a 10 to 0 point scale, so we'll be nerding all over the place today. You've probably all seen the first meme. 2 old photos of Max Planck, one before discovering quantum physics and one afterwards, in which he has a very innovative haircut. The issue is that funny hair pic of Planck almost certainly wasn't taken after his discovery, but before it, like the other photo. Planck presented his seminal work in which he introduced the quantum of energy in 1900. He was born in 1858, so by this time he'd have been in his early 40s. Does the person in this image look like someone in his early 40s to you? Maybe Brian Johnson should have a close look at quantum mechanics. Well, I piped Planck's photo into an AI and it dated him at 36 years. Agreed, that might not mean much given that the photo is pretty crappy and AI is only so smart, but it's a hint. It also dated 45-year-old Johnson at 39, so at least his money wasn't entirely wasted. But back to Planck. Another way to date the photo is to compare it with other photos of him. For example, this one in which he has the same haircut. According to LME, it was taken in 1895. According to Getty Images, 1890. That's kind of consistent with the AI age of 36, and either way, clearly before he introduced the quantum. There's also this family picture. How old would you think these children are? I'd guess the young boy is maybe 7 and the older one looks like trouble, so maybe around 14. Maybe I'm off by a year or 2, but can't be much. Well, this is Planck's second son, Erwin. He was born in 1893. If he's 7, that dates the pic to 1900. This is Planck's first son, Carl. He was born in 1888. If he's 14, that dates the pic to 1902. So this pic would indeed have been taken briefly after Planck put forward his quantum hypothesis. But no funky hair. I told you this would be totally unfunny, guys. The other issue I have with this meme, yes, I have issues, is that Planck didn't really discover quantum physics. He just introduced a quantum of energy. Yes, that's something with quantum and something with physics, but it's not what we mean by quantum physics. It's not like everything with butter and flies gives you butterflies either. Planck's work was a super important stepping stone for quantum physics, but what we mean by quantum physics today was discovered by Heisenberg with his uncertainty relation, and Schrödinger with the Schrödinger equation, and Bohr and Pauli and Dirac and so on. Okay, so here's my rating. This meme is undoubtedly funny just because of the hair. I'll give it a 9. But it's neither accurate nor educational, so let's say 2 on both counts. Next meme is the Unfaithful Boyfriend as an observer who looks after the observed quantum state while every other possible quantum state is outraged. My reaction to that was about that of the girlfriend. I think it's supposed to illustrate the idea that in quantum mechanics, before a measurement happens, there are many possible outcomes. But you only see one, and the other possibilities just disappear when you don't observe them. That's the infamous collapse of the wave function, of which more later. So clearly that's not what's going on with the boyfriend. He may be a little indecent, but he didn't make his girlfriend disappear. However, in the many worlds interpretation, which we just talked about the other week, all the other possible outcomes actually happen, each in its own universe. So I guess we will have to use the many worlds interpretation for this meme, and the lesson is that the girlfriend will be outraged in any possible universe. I don't find this meme particularly helpful because, first, you don't actually need many other possible outcomes. A single one would do. And in quantum mechanics, the other possible outcomes are all different and not copies of each other. How am I doing with the nerding? Honestly, too much? Nevertheless, I'll give it a 7 for accuracy because it conveys the idea that the observer gets to see only one particular outcome while the rest of the wave function is being ignored, but a 3 for education because it suggests that you need copies of the thing that you don't observe, and that doesn't make any sense. And yeah, it's funny because the Unfaithful Boyfriend is kind of funny, so a 5 on the funniness scale. Next meme are Schrödinger's plates that are both broken and not broken until you open the cupboard door. This is again about the measurement update in quantum mechanics. In quantum mechanics, any system is described by a wave function that contains different possibilities for the measurement outcomes. You don't know which will become reality until you make a measurement. The most famous example is Schrödinger's cat. The poor cat is both dead and alive, so the story goes, until you open the box, because it was both killed and not killed by an atom that both decayed and didn't decay. Schrödinger used this example to illustrate that if you believe quantum mechanics is correct, then you must also believe in absurdities like dead and alive cats. But back to the plates. It doesn't make any sense to me. The plates are obviously not broken. You can see they're not broken. So I give this an accuracy of 1, because at least whoever did this had heard of Schrödinger's cat and something with a box, I guess. Effectiveness is not so bad, because it gets across that a measurement makes a difference, so I give this a 5. The image itself is kind of amusing, so I give this a funniness rating of 7. Next we have good old Albert Einstein with a pipe saying particles faster than the speed of light, pics or it didn't happen. I believe this is alluding to Einstein's famous remark about spooky action at a distance, which is again about the collapse of the wave function. The collapse is also sometimes called the update or reduction of the wave function. It's all the same thing. Problem is, this collapse, update, reduction itself is unobservable. This is why Einstein, reasonably enough, argued that the collapse of the wave function is not a physical process. It's not something that actually happens to a particle. It just describes the update of our knowledge about the particle. This is why he thought quantum mechanics is incomplete, because it's missing information. That's the hidden variables which would encode this missing knowledge. So the meme is very accurate. 10 out of 10 captures Einstein's attitude very well. But if you don't know that it's referring to the collapse of the wave function, I'm not sure you'll understand what it's even about. So I give this an effectiveness of 2. And it didn't exactly have me on the floor laughing, so a funniness of 3. Every time a science fiction show can't explain what the heck is going on, they chalk it up to quantum physics. This is totally true. I give it an accuracy of 10. It's not just sci-fi, it's also biology, but let's not go there. This meme is also really funny. I'll give it a 9, but it doesn't actually convey any information about quantum physics, does it? So an effectiveness of 1. Next up is the puppet monkey. It pops up in my socials constantly, and I'd be surprised if you haven't seen it before. This meme has me going, ah! It's supposed to illustrate the double slit experiment with single photons. This experiment gives a different result depending on whether you know which slit the photon went through. If you don't know, the photon behaves like a wave, goes through both slits and interferes with itself, creating an interference pattern. If you do know, you collapse the wave function, and afterwards the photon behaves like a particle. It goes through only one slit, and you get just 2 stripes, one for each slit. Or so the story goes. I've seen this illustration in countless images and videos. The problem is, it's wrong. It's not what the double-slit experiment looks like. Let's say you know which path the photon went because you just blocked one of them. Then you'll get a single-slit diffraction pattern. And the single-slit diffraction pattern looks very much like the double-slit interference pattern. Here is how this looks like in reality. Now, if you just overlay the two single-slit patterns, you do not get the double-slit pattern. That much is correct. With two slits, you have more interference, so to speak. But you definitely don't get these two stripes. The photon is still a wave, even if you know which slit it goes through, and it still interferes with itself. That said, I think this meme is highly effective in conveying the idea that it matters what you measure, whether you know which path the photon went. So 10 points on effectiveness, but 2 points on accuracy, and it's kind of half funny, I think, so I'll give it a 5. By the way, this video comes with a quiz on quizwithit.com. Even better, if you subscribe to Quiz With It, you can collect points from all our videos and you get free access to the transcripts with links to all references. It's an easy way to support both our channel and hopefully your memory, so go and check it out. The next meme about quantum mechanics recently made rounds somewhere in my corner of the internet. It's bad, guys. It's really bad. Where to even begin? Okay, let's remember what the deal is with Bell's theorem. Bell's theorem says that any theory which is local and fulfills an obscure assumption known as measurement independence must obey an inequality for correlations between certain measurement outcomes. We know from experiments that in reality this inequality can be violated. This is what the 2022 physics Snowball was about. So if your theory explains observations, it must either be non-local or violate measurement independence or both. It's not much of a secret that personally I think it's insane to throw out locality, therefore measurement independence is violated, but I digress. What the observations certainly do not tell us is that hidden variable theories have been ruled out. So this meme makes zero sense. The most famous hidden variables theory that explains observations is Bohmian mechanics. It's both non-local and violates measurement independence. A correct version of this meme would look like this. Observations plus the assumption of locality mean that measurement independence is violated. Yay! I give this a 0 on accuracy, a 0 on effectiveness, and I don't think it's funny to make jokes about serious accidents, so a 0 for funniness. Nope, not funny at all. Then we have the ambiguous which way sign, which I frequently see as an example for a particle which goes both ways at the same time, for example a photon that encounters a beam splitter. I find this pretty funny, not just because of the botched paint job, but because the photo was taken in London and it's kind of how I feel each time I need to cross the street there. So I'll give it a 10 for funniness. But I'm not sure it's terribly effective. If you don't already know that a quantum particle does this thing with going both ways, you might think it just doesn't know where to go and randomly picks one direction. So I'll give it a 2 for effectiveness. When it comes to accuracy, I think that's how quantum paint works indeed. 10 out of 10. Next meme is an explanation for the electron spin. Imagine it's a ball that's rotating, except it's not a ball and it's not rotating. Okay, I admit that I laughed about this because it's how it is. You see, the spin is a quantum property of a particle. It behaves similar to, but not the same as, the angular momentum. The angular momentum is a quantity that describes spinning objects. This is why the thing's called spin, would you believe it? But it's not really a spin in the sense that the particle isn't spinning. And the particle, of course, is not a ball. It's described by a wave function that's in general more like a fluffy cloud. So imagine a ball that's rotating, except it's not a ball and it's not rotating. That's a 10 for accuracy. Also 10 points for funniness because it's true that physicists really say shit like that. And a 3 in effectiveness because you still don't know what spin is, do you? And the last meme for today is the disappointed black guy. He's looking forward to learning quantum physics in one lesson, just to find that the one lesson is several weeks in one sitting. I think that's somewhat of an exaggeration, but pretty funny. I'll give it a 9. It's also highly accurate. You're not going to learn quantum physics in 10 minutes, so that's a 10 on accuracy, but it doesn't convey much information, so a 1 for effectiveness. I hope you found this video suitably unfunny. Did I forget your favorite meme? Let me know in the comments. You'll not understand quantum mechanics by watching a 10-minute video. It's not how it works. If you want to understand the topic, you'll have to actively engage with it. Luckily, I know a free and easy way how you can learn quantum mechanics at brilliant.org. Brilliant offers interactive courses designed to make learning fun, engaging and effective. Whether you're a student looking to ace your exams, a professional aiming to sharpen your skills, or simply someone who loves to explore the world of science and maths, Brilliant has something for you. What sets Brilliant apart is its hands-on approach to learning. You won't find boring lectures here. Instead, you'll tackle problems with smart visualizations and follow-up questions. It really helps you develop a deep understanding of even complex concepts. I found Brilliant's courses to be highly effective to learn something new, and I've worked together with them to develop a course on quantum mechanics. This course will introduce you to the basics of wave functions and superpositions, probabilities, entanglement and interference, and with that background knowledge you can then continue to learn more about maybe quantum computing or quantum objects. And you can try it yourself for free. Sign up using our link brilliant.org/Sabine. You'll get free access to everything Brilliant has to offer for 30 days, and the first 200 subscribers using this link will also get 20% off the annual premium subscription. Thanks for watching. See you next week.